1,400 hours, South China Sea. 3 days after China's National Day Parade had broadcast the DF-27 hypersonic missile to the world as proof that the era of American naval dominance was ending. The USS Milius was on freedom of navigation patrol when the first tracks appeared on the AN/SPY-1D radar, 12 of them. Moving at Mach 5+, weaving, altitude changing, arriving in a spread pattern designed to hit the ship from multiple vectors simultaneously. Time to impact under 3 minutes. Beijing's calculation was surgical and cold. If the Milius survived, they would have extracted every piece of intelligence they needed about American intercept timing, missile expenditure sequences, and the exact thresholds at which the Aegis system prioritizes targets under a saturation scenario. If the Milius didn't survive, the message to every Pacific ally would be written in the smoke column, rising from a $2 billion destroyer. Either outcome served the People's Liberation Army Navy's strategic objective. Or so the planning cell in Sanya believed. Here is what the DF-27 actually is, as opposed to what the parade commentary described it as. It is a genuine hypersonic glide vehicle, a maneuvering warhead delivered to altitude by a ballistic booster, then released to glide at hypersonic speeds on a low, non-ballistic trajectory that removes it from the predictable parabolic arc that makes conventional ballistic missiles relatively straightforward intercept problems. Its radar cross-section is small. Its terminal approach speed negates reaction time for systems that rely on physical intercept geometry rather than predictive fire control. Against a single-layer point defense, it represents a legitimate threat to any surface combatant currently afloat. Against a networked multi-layer architecture with predictive fire control and an airborne sensor node providing geometry that a surface ship's radar cannot compute alone, the picture changes. The E-2D Advanced Hawkeye, orbiting at 24,000 feet, had the launch signatures before the Milius's own radar had fully resolved them. The E-2D's AN/APY-9 radar, operating at altitude, sees the geometry of a hypersonic trajectory differently than a surface ship's radar does. The elevation angle provides a look-down capability that closes the horizon gap that sea skimming and hypersonic low-altitude profiles exploit against surface sensors. By the time the track data arrived on the Milius's combat displays via Link 16, the Aegis Baseline 10 system already had predictive trajectory models running on all 12 contacts. The Swarm Slayer tactic that Beijing's targeting planners had built into the attack sequence was not naive. It was a studied solution to a specific problem. How do you defeat an intercept system that is fast enough to engage every inbound round sequentially? The answer the plan developed was to force simultaneous classification decisions by mixing high-fidelity decoys into the formation. Objects that produce radar returns, thermal signatures, and flight profiles consistent with real warheads but carry no functional payload. If the defending system spends interceptors on decoys, the real warheads get a clear lane. If it delays to discriminate, the closing speed removes the engagement window. The Aegis system's response began at 14:01 hours and 14 seconds. 8 SM-6 Block IA missiles left the Milius's Mark 41 VLS cells in a ripple sequence that put all 8 rounds airborne within 4.2 seconds. The SM-6 is the right weapon for this problem for a specific technical reason. Its active terminal radar seeker acquires independently, meaning the fire control solution does not require the ship's radar to maintain continuous illumination of each target throughout the engagement. The missiles climbed to altitude, receiving mid-course guidance from the E-2D's data stream rather than the ship's own SPY-1D, which freed the surface radar to continue tracking the entire formation rather than dedicating beams to weapon guidance. 6 of the SM-6s found their targets cleanly. The DF-27 airframe at hypersonic speed, meeting a 140-pound fragmentation warhead detonating in proximity, does not produce a miss or a partial kill. The kinetic energy of the collision between the warhead's tungsten fragments and the incoming vehicle at combined closing velocities above Mach 6 is sufficient to structurally destroy the airframe regardless of where the fragments impact. 6 tracks cleared from the display. The remaining 6 contacts continued inbound. The decoys had performed their function. 2 of the SM-6s had committed to intercept solutions on high-fidelity decoys before their seekers resolved the actual warhead/decoy discrimination in the terminal phase. The decoys were gone. 2 genuine DF-27 warheads had used the confusion window to press inside the SM-6 engagement basket. The ESSM Block 2 salvo went out at 14:01 hours and 51 seconds. 8 rounds. The ESSM Block 2's active radar seeker is the element that made this engagement work against the specific tactic Beijing had employed. In the final seconds of its flight, as the seeker resolves the target, it performs a classification check against the target's electronic signature. A decoy that generates radar reflective noise without the specific thermal plume and structural return of a real hypersonic warhead fails that classification, and the seeker rejects it. Not as a miss, but as a deliberate reprioritization. The ESSM's guidance recomputes and looks for the real target in the same approximate geometry. 4 of the inbound DF-27 warheads were intercepted in this layer. 4 more decoys that had been running interference were destroyed in the same sequence. 2 contacts survived into the terminal zone. Range to ship, 9 nautical miles. Time to impact at current velocity, approximately 9 seconds. The Milius's Mark 45 Model 4 5-inch gun had been tracking since the moment the inner engagement zone was breached. The engagement solution for a hypersonic maneuvering target at close range is not a direct fire problem in any conventional gunnery sense. The target's velocity and maneuverability mean the gun cannot aim at where the missile currently is. It aims at a computed point in 3-dimensional space that the missile will occupy at the moment the round arrives, based on the Aegis system's predictive trajectory model running continuously on the target's current flight parameters. The gun fired 4 rounds in rapid sequence. The first round detonated its proximity-fused warhead at a computed kill box ahead of the first inbound DF-27. The fragmentation pattern from a Mark 80 series proximity fuse at that engagement geometry produces a conical debris field that the target flies into rather than being struck by. At Mach 5, the DF-27 intersects that debris field before any maneuver command its guidance can generate has time to execute. The first track cleared. The second, DF-27, was inside 2 nautical miles before the gun's fuse setter mechanism flagged a cycle malfunction from the sustained high-rate fire. The round chambered. The fuse setter did not complete its programming sequence. The gun went to mechanical hold. The Phalanx Block 1B close-in weapon system operates on a different principle than every other weapon in the Aegis defensive architecture. It has no human in its decision loop. It does not receive targeting data from the ship's combat system. It operates as a fully autonomous radar and gun system. Its own radar acquires, tracks, and fires without any external command input, which is the specific design characteristic that makes it the terminal defense against exactly this scenario. A threat that has survived all human-managed layers and is now inside the reaction time envelope for any system that requires a command authorization step. The Phalanx's fire control radar acquired the second DF-27 at 1.4 nautical miles. The system computed its engagement solution, spun its 6-barrel M16 8-Vulcan cannon to operating speed, and opened fire in a sustained burst at a rate of 4,500 rounds per minute. The rounds are not individually aimed. The system creates a dense geometric pattern of 20mm tungsten penetrators in the predicted flight path of the incoming warhead. A DF-27 airframe at Mach 5 intersecting that pattern at 0.8 nautical miles does not experience the impact as a series of discrete strikes. It experiences simultaneous structural loading from multiple penetrators arriving faster than any damage propagation can occur. The airframe's structural integrity fails in under 1 millisecond. The warhead did not function. The debris field impacted the water 400 meters off the Milius's starboard beam. In the Combat Information Center, the display cleared. No remaining inbound tracks. All 12 original contacts, 6 genuine warheads, 6 high-fidelity decoys accounted for. The engagement had run from first contact to terminal intercept in 4 minutes and 31 seconds. The intelligence product of those 4 minutes and 31 seconds ran entirely in the wrong direction from what Beijing had intended. Every parameter of the engagement, the SM-6 engagement timing and range, the ESSM terminal seeker discrimination behavior, the MK-45 predictive fire solution geometry, the Phalanx activation threshold, had been captured in real time by the E-2D's passive collection systems and by the signal's intelligence assets monitoring the South China Sea from outside the engagement area. The plan's targeting cell in Sanya would receive an after-action assessment that contained what the attack had revealed about American intercept architecture. What they would not receive was the parallel data set of what the defense had learned about DF-27 terminal guidance behavior, maneuver envelope, decoy separation sequencing, and electronic signature under terminal engagement conditions. That data belongs to the Milius's after-action record now. The USS Nimitz's flight deck had been at strike launch alert since the first DF-27 tracks appeared on the network. 12 FA-18E Super Hornets and 4 EA-18G Growlers launched at 14:08 hours, 22 minutes after the engagement began. The Growlers flew jamming support ahead of the strike package. The launch facility that had originated the DF-27 Salvo, a mobile transporter erector launcher site that U.S. reconnaissance satellites had been tracking since it departed its garrison 3 days earlier, had not completed its reload sequence when the JDAM-ER weapons arrived. The strike damage assessment confirmed the launcher and its associated fire control equipment as destroyed. The Milius resumed its assigned patrol track at 14:38 hours. No crew casualties, no structural damage. 34 interceptors expended against 12 inbound targets. The honest version of what happened in those 4 minutes requires acknowledging the margin that existed at the end. The Mark 45 fuse setter malfunction is not a dramatic flourish. It is the kind of mechanical failure that sustained high-rate fire imposes on precision equipment. And it happened at the worst possible point in the engagement sequence. The planned saturation tactic succeeded in reaching the terminal defense layer with a live warhead. The phalanx resolved it, but the scenario in which the phalanx had already been degraded by a prior strike, or in which 2 warheads arrived simultaneously at that range rather than 1, produces a different terminal accounting. Beijing's strategic miscalculation was not in the technical performance of the DF-27. The weapon performed within its design parameters on every engagement metric except one, surviving the architecture it was aimed at. The miscalculation was doctrinal. The Swarm Slayer tactic was designed to defeat a single system point defense by forcing it to make sequential intercept decisions against a mixed warhead/decoy formation. It was not designed to defeat a multi-layer networked architecture with 3 distinct intercept mechanisms operating on different physical principles: kinetic interceptor, proximity fragmentation, and sustained fire saturation, each of which covers the specific failure mode of the layer above it. A tactic optimized for one defensive architecture, applied against a different one, produces a different result. The South China Sea is not a testing range. The Milius's patrol continued on its assigned track. The DF-27 was the headline weapon of a parade that was meant to demonstrate that the Pacific was no longer American water. The engagement on this afternoon added a data point to a much longer argument about what actually governs access to those waters. Here is the question worth placing in front of anyone who followed this engagement. The plan's next design iteration on the DF-27 employment doctrine will incorporate what they observed: the SM-6 engagement range, the ESSM seeker discrimination window, the MK-45 fuse setter limitation under sustained fire. If the next salvo is structured to exploit specifically the transition point between the ESSM layer and the MK-45 layer, arriving in tighter time compression that forces the gun into its sustained fire limitation earlier in the sequence. What does the Aegis system's response architecture look like, and where does the directed energy component need to fit into the defensive sequence to address that specific saturation geometry? Leave your analysis below.